infinity. All right, there's two parts to the limit that can relate to infinity. There's the y values and the x values. Okay, but let's jump into this. There's three parts to this. This is part one. When we're talking about limits, we're talking about limits at infinity. We're considering vertical asymptotes and horizontal asymptotes. These limits are related to vertical asymptotes, as you can see on the graph over here. So here we're approaching -2 from the left-hand side. And when we approach -2 from the left-hand side, you can see that we're approaching negative infinity on the y-axis. So that would be our y value. We consider this to be the unbounded answer, okay, because it's going towards negative infinity. Now, for the approaching -2 from the right-hand side, we're also approaching infinity, but this time it's approaching positive infinity, which is still also considered unbounded. But now, the left and the right are both approaching opposite infinities. One's approaching negative infinity, one's approaches positive infinity. And so you would call this does not exist. This limit does not exist because the left and the right approach separate infinities. All right, let's look at this other infinity that's approaching 0 from the left-hand side. For this one, we're approaching negative infinity from the left, and then from the right, we're also approaching negative infinity. In this case, we're both approaching the same infinities, and so you can say that the limit of f as x approaches 0 is negative infinity because both the left and the right approach the same infinity, or you can say it does not exist. This part's kind of confusing, but both of these answers are correct for this one. Okay, so when you guys are reading the limit, remember which represents the x value, which represents the y value. Okay, this is your y value and this is your x value. Okay, different things here. Whenever the x value is infinity, we're going to be talking about horizontal asymptotes. When the y value is infinity, those are your unbounded answers. All right, let's fill in these words right here. When approaching negative infinity or positive infinity, the limits are asking what y value is the function approaching when we go to the left or to the right on the graph. Okay, and this one right here is the left side of the graph, and this one right here is the right side of the graph. Okay, horizontal asymptotes of a function tell us what y value the function will end up at. Remember, horizontal asymptotes are not like vertical asymptotes. Curves will never pass through a vertical asymptote, but they can pass through a horizontal asymptote. Curves are attracted to asymptotes, which means they will always end up approaching it. Okay, so even if a function passes through a horizontal asymptote, it'll come back to the asymptote because they're attracted to it. Okay, they're always approaching it. When looking for horizontal asymptotes, and I use the word "it" right here. I want you guys to try not to use that word in this class, and so I crossed it out and put that y value. It's approaching that y value. Okay, when looking at horizontal asymptotes, you are considering the denominator and the numerator degrees. Looks like I forgot an S right there on the degree, so go ahead and add that on there for me. Okay, let's look at these graphs down here. First we have this graph, 2x minus 1 over x, and for this limit we are approaching positive infinity. Now when we're approaching positive infinity, we're approaching the right side of the graph, and as you can see, I think the asymptote is pretty clear. The horizontal asymptote is right here at 2, and this graph is approaching the 2. And so on the right side of the graph, our limit is 2. And then for the left side of the graph, the negative infinity side, it looks like the graph is also approaching 2. Now there are going to be special graphs in the future when there's two different horizontal asymptotes, but we're not going to worry about those just yet. We're just looking at the introduction. All right, the next one, 2 over x, when we're approaching the right side of the graph, this time the horizontal asymptote is at 0, and we're as we go to the right, we're approaching the y value 0. And then for, looks like this one I accidentally put a positive infinity. You need to put a negative infinity there. So for the last limit, as 2 over x, the limit of 2 over x as x approaches negative infinity is also 0. We can see it's just approaching that same asymptote. Okay, so that's our answer for that. And then go ahead and cross out this bottom part. I don't think that part is very important, but there you go. There's part 1.